Okay, so the last section in chapter 9 has to do with multi-step synthesis. So making a compound from another compound that has more than one reaction in a row. And so anything with two or more reactions would be called multi-step synthesis. Most of the things that we're going to talk about have two steps. There are a few that have more than two steps, and that definitely gets pretty complicated. This is one of the biggest things to learn and to practice if you take an organic chemistry class. It's a pretty long learning curve, and it takes a long time to get good at synthesis. It's something that you practice all year. It's definitely not a one-time thing. So let's get started. So synthetic strategies. Before you think about a synthesis reaction, so the book goes through some ways that, to look at your compounds and think about questions to ask before you get started. And this first section is on one-step synthesis, so you can think about what is being added. Are you going to make an alcohol? Are you going to make a bromine? What types of compounds will you add for that? The next thing is regioselectivity. So that would be, in our case for this chapter, Markovnikov versus anti-Markovnikov. Which carbon are things going to get added to if it's not symmetrical? And then lastly, stereochemistry. Is it going to be cis or trans? What type of stereocenters? Thinking about will it make a mixture of enantiomers? We are not going to focus so much on that. That definitely gets super complicated. We're mostly going to focus on the first two questions. So here's a one-step problem, which we're going to go through these steps and sort of think about how we would do this this reaction. How do we get from A to B? What are we going to add, and how are we going to get there? So looking at the product, and this is a theme in synthesis. You always want to start out with the product and sort of think backwards. We're going to add across a double bond. We're going to add a hydrogen and an alcohol, an H and an OH. And in this pattern, because it's an unsymmetrical alkene here, one carbon is less substituted, the other carbon is more substituted, and the OH is adding to the more substituted carbon, so that would be the Markovnikov addition. And then we would go back in our memory and think about what reactions that we know will add an alcohol Markovnikov. And we know two ways to do that. And I listed both of them here to sort of cover all, because this is like an explanation. If I had to, was taking a test and had to pick one, then I would pick one of these. So if we add water and acid, or H3O plus, it will add Markovnikov. It will put the OH here. This is a safe bet in this case because the carbocation that's going to get formed is tertiary, so it is unlikely to rearrange. So where acid and water could be problematic, it's not problematic in this case. And that is probably what I would choose if I were, picking something for this reaction here. The other way that you could make the Markovnikov addition would be the two-step mercuric acetate in water, followed by reduction with sodium borohydride. That will also give Markovnikov addition. If the first step was likely to rearrange, then the second step would be the perfect choice. But in this case, either one would be right. And a lot of times when you're talking about paper synthesis, like writing things down on paper, there are often times where it doesn't matter what you pick, and either one would be correct. In the lab, you might try both of them and see which one would work better, but on paper, you have to make a choice. So that's one step. And we've actually done some of that already, like how do you do this reaction? What do you add? That was sort of a one-step synthesis choice. The next couple things are definitely more complicated. So now we're going to do a two-step reaction. So we're looking at the starting material, which has the bromine on the left, the second carbon, and then the product has the bromine on the third carbon. How would we get from, you could think of it as, how would we get from A to C? And we're going to have to go from A to B and then B to C, and we have to show all the steps, and each step is going to be its own reaction. So one of the things about the synthesis, especially when it gets more complicated and when we've learned lots and lots of reactions, is that you want to start with the product and kind of work backwards, because if you think backwards one step at a time, that's usually the best way to think about how you're gonna get there. And there's this convention that we use, and I think your book doesn't actually introduce it till later, but I introduced it now, and that's this funny looking arrow, this kind of double arrow. This is called a reverse arrow. It's used in this method of going backwards is often called retrosynthesis, like backward synthesis. So here's my final product. How am I going to make this product? What would it be going backwards one step? So you want to recognize that you can make this final bromine from this alkene. And then we could make this alkene from the starting bromine. Like, we know how to go from here to here, from A to B, and then from B to C. The tricky thing is, when you see it done, the tricky thing is coming up with what's going to be in the middle. So now that we've figured out how to go backwards, the intermediates that we're going to have, now we're going to go in the forward direction, and typically in the forward direction we label all the reagents that we're going to use. You could label the reverse arrows. I don't usually do that, but you could. Okay, so you want to think about all those questions that we would be asking. So we have a bromine and we want to make this specific alkene. This is the most substituted alkene. So we would use a base to do an E2 elimination, and we'd want to use a small base because the small base would make the more substituted alkene as the major product. This is rather than a bulky base, which would eliminate over on this side over here. And because we want to make the more substituted alkene, we would use the small base. So then, starting with the alkene, we're going to add HBr, and it will add a Markovnikov addition, which puts the bromine in the more substituted carbon. And I've labeled notes in blue. If I were writing this on a test or something, I would not necessarily write what I wrote in blue here, because those are just sort of notes for myself to talk about why I would choose this. You would just write the reagents above the arrow and show all the intermediates. And that's a two-step reaction. Two-step synthesis. So the next pattern that we see in this chapter is we're starting with one alkene, and then how would we go from this alkene to the final alkene. We cannot do this one step. We don't know of any reactions that will take a double bond and move it. So again, we're going to have to use more than one step. So again, starting with the final product, and we're going to go backwards. So we're going to use that backwards arrow, that retrosynthesis arrow. Here's our final product. We can make this alkene from this bromine compound, and we could make this bromine compound from the original alkene. Most of these are going to be two steps, so you're going to look at there's a couple of them in your worksheet that are not, but I'm going to point those out to you. So now, starting with the starting material, going in the forward direction, we're going to label all the reactants. So going in the forward direction, starting with the double bond, we're going to add HBr, which adds hydrogen and bromine across a double bond, and it will put the bromine on the more substituted carbon, and there's no likely rearrangement here. And then in the second step, it's going to be an E2 elimination, but we want to eliminate to make the less substituted alkene, which means we're going to have to pull off a hydrogen from the less hindered carbon, which means we're going to need to use a large bulky base, a strong base, but a bulky base in order to make the less substituted alkene. And again, my notes here are in blue. If I were writing a key or writing a test, I wouldn't necessarily write what I wrote in blue. They're just notes to explain. So those are the two basic patterns that we see in this chapter. We don't actually know that many reactions yet. So all the synthesis problems that I could find, they're not all the same, but they have sort of the same basic patterns where they all involve substitutions, eliminations, and addition reactions. So because we haven't covered that many reactions yet. In the worksheet that's in your packet, and I've put another copy up on Schoology as an assignment, there are, I think it's 8 or 9 synthesis problems. That's really quite a bit of practice, which would be great. And the more you do, you'll see that, again, a lot of them have similar patterns. So once you get the hang of it, it will definitely be easier. I picked one of them to do. I picked C. My first thought was to make a video that showed how to do all of them, kind of like a video key. But to be honest, watching me do synthesis problems isn't really going to help you. Just an idea of like how to teach this, or how I've been thinking about how to do this for a while now. This was what I was worried about teaching on video, because it's so much easier to talk about it in person. And to be honest, this is really hard to teach because a lot of synthesis is intuition, and it's really hard to teach that. Watching a video, I worry because watching someone else do the problems makes it seem easy, and this is definitely one of the hardest things in organic chemistry. You start it early on in the year, and you keep it up. As you learn new reactions, you practice synthesis absolutely the whole year. If you take more chemistry classes, you can take specialty classes for synthesis, and literally it's something that you can keep learning. There's no such thing as someone who just like, oh, I know synthesis now and I can do any problem. It's something that keeps getting harder and harder the more you get into it. So this is problem C, which is in that list of problems on the worksheet and in your packet. Just a note, there is definitely not enough room on that page to do these. You're going to need to do these on a separate piece of paper. I'm putting up a worksheet that has the problems more spread out, so you could do them on the paper if you would like. So again, we're going to work backwards, starting with the product, thinking about how we would make that product going backwards one step. So we know that we can make the alcohol going backwards from the alkene, and that is the anti-Markovnikov reaction. And we can make the alkene from an alkyl halide. I'm always picking bromine here, just because that's the reaction. Sometimes you have the choice of bromine or chlorine, and it doesn't really matter which one you pick. Bromine is sort of my go-to halogen that I usually pick. So now we're going to go in the forward direction. And again, I'm making notes in blue that are just like my explanations, which you can when you go to do your own problems, you can make notes if you want to, but you don't really have to. It's not required. So starting with the starting bromide, we're going to add a small base, which will, I picked the wrong one here. Sorry. Sorry, this is a small base because it's making, I wrote the wrong thing here. Bulky base is correct, and I should have written the t-butoxide here, and it's going to make the less substituted alkene, which is the correct one here. I don't have a pen here to fix it. So pretend that this says t-butoxide. Bulky base here is correct, so you should correct it in your notes. And then starting with this alkene, we are going to add hydroxide across the double bond, but we want the OH to go in the less substituted position, which is the anti-Markovnikov product. So to do that, we would add BH3 in the first step, followed by the oxidation with peroxide and heat and sodium hydroxide to give us the alcohol. You don't have to show these two-step reactions that we learned. You don't have to show both steps. It's really common to write the 1 and 2 and just write the overall reaction. Let me fix this. Let me fix the so we would use sodium or potassium t-butoxide to give us the least hindered alkene here. Sorry about that. So you should work the synthesis problems in the worksheet. Definitely take your time. Look at your notes, but as you look at your notes, try to start to memorize the reactions. You don't want to have to flip through your notes every single time you do a synthesis problem. You want to sort of have a good dictionary of reactions, and then as you learn new reactions, we're going to make more and more complicated synthesis problems. On that worksheet, I will mark them on the worksheet that I post. The last 2 problems are more than 2 steps. They're definitely a little bit more complicated. I will give you feedback on your problems, and then I will post a key after everything is due. And good luck.